Welcome to another Explainer. Today, we're unpacking the absolutely incredible survival story of our ancestors. We're going to look at how early humans didn't just scrape by, but actually thrived against some of the most impossible, genuinely terrifying odds our planet has ever thrown at a species. Okay, let's just plunge straight into the incredibly hostile world of the Pleistocene to uncover the real secrets of human adaptability. I want you to imagine a world entirely devoid of modern comforts. A world where extreme climate shifts, sudden natural disasters, and, massive predators were just daily, life-threatening realities. How on earth did a seemingly fragile primate species actually make it through all of that? Section 1. The Spark of Civilization. Our journey begins with what is arguably the greatest technological leap in human history, and that's the mastery of fire. Now, it wasn't like someone just invented the match overnight, right? Mastering fire was this slow, gradual evolution over immense stretches of time. It likely started over 1.5 million years ago with our ancestors bravely, or maybe just opportunistically, grabbing embers from wildfires sparked by lightning. Then, by 1 million years ago, we actually see microscopic traces of wood ash in South Africa. Jump forward to 780,000 years ago, and there's evidence of humans cooking fish in a cave in Israel. But that definitive jump to deliberately making fire on demand whenever they wanted, that didn't appear until about 400,000 years ago in eastern England. The sheer game-changing versatility of this new tool literally cannot be overstated. Fire didn't just keep the terrifying predators of the dark at bay, though that was a big plus. It radically expanded the geographical zones where humans could actually survive by giving them essential warmth in freezing environments. Plus, it allowed early humans to burn and clear out brush to manage their biomes and make hunting a lot easier. And fundamentally, it extended daylight. This completely shifted how our ancestors used their time. Which brings us to Section 2, the cooking hypothesis. See, the true power of fire wasn't just external. It wasn't just a tool you held in your hand. It fundamentally changed our biology from the inside out through what scientists call the cooking hypothesis. By softening up tough meat, breaking down raw cellulose, and neutralizing plant toxins, cooking drastically increased our net energy gain. To put that in perspective, your caloric intake from cooked starches improves by up to 35% compared to eating them raw. And for cooked proteins, it shoots up by a massive 45 to 78%. It vastly reduced the energy our bodies had to waste on just chewing and digesting. So the absolutely crucial point here is that those late nights around the campfire literally grew our brains. The human brain is a massive energy sink. It demands high metabolism, and cooked, nutrient-dense food provided exactly that high-octane fuel. Furthermore, hanging out around the fire extended our modern waking day to roughly 16 hours. This shifted our circadian rhythms way beyond other primates, who basically just went to sleep as soon as the sun went down. This extra time likely fostered social complexity, storytelling, and the development of language. Think about that for a second. Our modern intelligence was quite literally cooked into existence. And with this biological and energetic upgrade came what archaeologists call behavioral flexibility. Our ancestors weren't just merely surviving the elements anymore, they were innovating. A perfect example of this is from 164,000 years ago at Pinnacle Point in South Africa. Early humans there were systematically using fire to heat-treat silkrete stone. They figured out that baking the rock fundamentally altered its mechanical properties, increasing its flakeability. So they could chip away at the stone to engineer far deadlier, far more precise arrowheads and tools. They were basically prehistoric engineers. Section 3. The Toba Catastrophe Theory. This newfound behavioral flexibility, our mastery of fire, our optimized diets, and our advanced toolmaking, was about to face its ultimate boss battle. Roughly 74,000 years ago, on the island of Sumatra, Mount Toba erupted in an event that truly defies modern comprehension. It was the largest explosive event of the entire Quaternary period. That's the past 2.5 million years. It sent thousands of tons of ash incredibly high into the atmosphere, accompanied by deafening noise and powerful tsunamis, before eventually collapsing inward to form a massive caldera. Now, to really understand the sheer magnitude of this, you have to compare Toba to historically devastating eruptions like Vesuvius in 79 CE or Krakatoa in 1883. Toba completely dwarfs them. It's not even a contest. It wasn't just a big volcano, it was a total Earth-altering cataclysm that completely reshaped the global atmosphere. To put a hard number on that for you, Toba expelled a staggering 2,800 cubic kilometers of magma. For context, that is the equivalent mass of more than 19 million Empire State Buildings. No joke. This blast instantly destroyed all life in its surrounding area, with intensely hot ash flows and coated vast swaths of the globe in a dark veil of sulfur and suspended gases. Because of the terrifying scale of the eruption, for years, scientists believed this event caused what became known as the Toba catastrophe theory. This theory hypothesized a decade-long volcanic winter, resulting in severe global freezing and mass vegetation die-offs. Even more alarmingly, they proposed that this environmental disaster caused a massive human genetic bottleneck, basically bringing us to the very brink of extinction by reducing the global human population to just a few thousand survivors.
But wait, Section 4, Surviving the Ash.
It's a bleak theory for sure, but recent microscopic discoveries have completely flipped this apocalyptic script. By extracting tiny bits of volcanic glass and ancient plant matter from deep sediment cores in places like Lake Malawi, which is over 7,000 kilometers away from the eruption, researchers unlocked a massive plot twist. That ash spread all the way across the Indian Ocean and deep into Africa, right where archaeological sites are currently being excavated.
When researchers meticulously analyzed those core samples, the data showed the volcanic winter actually wasn't an apocalypse at all. The cooling was relatively mild, peaking at a temperature drop of about 1.5 to 3.5 degrees Celsius. The dense aerosols cleared in 4 to 5 years, rather than decades, and critically, there was no massive vegetation die-off. Those East African ecosystems remained incredibly resilient.
Remember Pinnacle Point? That coastal rock shelter in South Africa where humans first heat-treated rocks to make better tools? Well, researchers went back to those very same coastal sites to see exactly what happened to the human populations living there when the Toba ash fell. What would they find in those deep layers of dirt? Using a highly advanced technique called optically stimulated luminescence to date the grains of sand, they found something absolutely astounding. At Pinnacle Point, human occupation didn't just survive the Toba eruption, it actually intensified. Seriously. Instead of dying out or abandoning the site, human populations there thrived, and their tool-making and foraging activities increased right through the ashfall in the immediate aftermath of the event. And this wasn't just some isolated incident either. Discoveries at the Shinfa Matema 1 site in Ethiopia further prove this incredible resilience. Scientists collected thousands of bones, eggshells, and arrowheads, and found microscopic fragments of Toba's volcanic glass sitting in the exact same sediment layer. This proves that early modern humans continually occupied these sites before, during, and after the super eruption, adapting to whatever local changes occurred. They didn't just survive the disaster, they completely outsmarted it.
So the big takeaway here is summarized perfectly by the researchers studying the Ethiopian site. Humans had the behavioral flexibility required to survive. It wasn't sheer luck. It wasn't a miracle that saved us from the largest eruption of the Quaternary period. It was our learned mastery of fire, our optimized diets from cooking, and our advanced tools that allowed us to adapt seamlessly to changing, arid conditions.
It really leaves you wondering about the sheer power of human ingenuity, both then and now, doesn't it? We started as opportunistic foragers grabbing glowing embers from brush fires, and we used that knowledge to grow our brains, build complex societies, and casually survive the greatest supervolcanic eruption in 2.5 million years. If they could do all of that with nothing but stone tools, learned knowledge, and a campfire, what are we capable of adapting to today? Thank you so much for joining me on this explainer, and keep exploring.